Hi students, this session will discuss about the stability problems and we will solve the problems using the routh-HURWITZ criteria. So the question is, the characteristic polynomial of a system is s raised to 7 plus 9s raised to 6 plus 24s raised to 5 plus 24s raised to 4 plus 24s raised to 3 plus 24s square plus 23s plus 15 equal to 0. Determine the location of roots on the S-plane and hence the stability of the system. So, characteristic polynomial is given and you are asked to find out the location of roots on the S-plane and also you have to find out the stability of the system. So, you can use routh-HURWITZ criteria to find the location of the roots on the S-plane. Also, you can use this criteria to determine the stability of the system. So, let us start doing problem by taking the characteristic equation. The characteristic equation is given in the question. So, we will write that first. So, in the characteristic equation, we will get two information. First one, you know that the highest power of s in the equation is 7. So, the order of the equation is 7. So, you can also find that since the order is 7 or highest power of s is 7, that means there are 7 roots for this equation. Okay, that is a basic mathematical knowledge. So, this equation has got 7 roots and the order will be 7. So, you have to find the location of these 7 roots. Okay, so that you should keep in mind. You have to find the location of these 7 roots. So, let us start doing the problem by creating the routh array. That is the first step, creation of the routh array. And routh array will be formed from this characteristic equation. You can see that this equation starts with the odd powers of s. See, the highest power is 7. So, this equation starts with the odd powers of s. So, we will constructing routh array. We will start constructing routh array by writing the odd power of s. So, first row will contain odd powers of s. See, here the first odd power is 7. So, we will write the quotients of s raised to 7, that is 1. And next we will go to the other odd power, that is s raised to 5 and its quotient is 24. And next odd power of s is s raised to 3 and its quotient is 24. And the next odd power of s is s raised to 1 and its quotient is 23. So, these all are the odd powers of s. So, we can write these quotients of these odd powers of s in a row, first, that is in the first row. So, we will start writing this. See, first we will write the row of s raised to 7, that indicates the row of odd powers of s. So, that will contain the quotients of odd powers of s. So, those quotients are 1, 24, 24, 23. So, row 1 is formed from the characteristic equation. So, next lowest power is s raised to 6. So, we will write that s raised to 6 just down the s raised to 7 and we will construct the row by taking the quotients of even powers of s. See, we will go to the characteristic equation again. You can see the first even power of s is s raised to 6 and its quotient is 9 and this next even power of s is s raised to 4 and its quotient is 24. And the next even power of s is s square and its quotient is 24. And the next even power of s is s raised to 0. That means it is 1. So, its quotient is 15. So, we will write those quotients in a row corresponding to s raised to 6. So, we will write 9, 24, 24 and 15. So, these two rows, that is row 1 and row 2 are formed from the characteristic equation. So, first row is formed by taking the even quotients of even powers of s and second row is formed by taking the quotients of odd powers of s. So, next we will find the next row, that is next row is s raised to 5. Before that you can see that in order to reduce the complications in doing the problem, we can reduce each row by dividing it by a single number. See here 9, 24, 24, 15 and it can be divided by the number, these all the elements of this row can be divided by the number 3. So, you can reduce this row. See, you can see here that so s raised to 6 will become 3, 8, 8 and 5. So it will be obtained from the row 2 by dividing it by 3. So the root array will be s raised to 7 and s raised to 6, and s raised to 6 elements will be replaced by this 3, 8, 8, 5. And next we want to find out the next stage, that is s raised to 5. So s raised to 5 will be obtained from the upper 2 rows. See, s raised to 5 entries will be obtained from the s raised to 7 and s raised to 6 rows. And here the equation we have discussed in the root array construction. See, this first entry will be obtained by taking the negative determinant of 1, 3, 24, 8 divided by this 3. See, first entry is obtained by taking the negative determinant of first two columns. See, first two columns of the upper layer, and that will be divided by this first entry in the s raised to 6. Okay, so we will get 1. So that steps is shown here, that is negative determinant of first two rows will be 3 into 24 minus 8 into 1 divided by 3. Similarly, next entry of 1 is obtained by taking the determinant of 1, 3 and this 24 and 8. So determinant is formed by 1, 3 and 24 and 8, that, and we will take the negative determinant of these two entries, these 4 entries, and we will divide it by this 3. So that step is 3 into 24 minus 8 into 1 divided by 3. So for finding the second entry in the s raised to 5 row, we will take the negative determinant of these two and these two, and that will be divided by 3. So, and next entry in the s raised to 5 is obtained by taking the determinant of 1, 3 and this column, that is 23 and 5, that will be divided by this entry 3. So we can find the every entries corresponding to s raised to 5 by taking the negative determinant of appropriate columns divided by the first entry in the s raised to 6. So we got the value s raised corresponding to s raised to 5. We will get the values 21.33, 21.33, 21.33. See, you can see that this row can be completely divided by 21.33. So we will get the entries 1, 1 and 1. So you can put it here 1, 1 and 1. Next entry, next row is s raised to 4 row. So it will be obtained from the upper 2 rows, that is from the s raised to 6 and s raised to 5. And similar procedure can be applied here. So for getting the first entry in the s raised to 4, we will take the determinant of negative determinant of 3, 1, 8, 1, and that will be divided by this 1. So that equation for finding the s raised to 4 is 1 into 8 minus 1 into 3 divided by 1. And the second entry will be second entry of s raised to 4 is obtained by taking the determinant of 3, 1 and next column, that is 8 and 1. This 8 and 1 divided by this entry 1. So the third entry will be obtained by taking the determinant of minus determinant of 3, 1 and 5, 0. Here there is no entry, so we will put it 5, 0 here. So negative determinant of 3, 1, 5, 0 divided by 1 will give the third entry. So that steps are indicated here. You can go through it. So you will get the entries in s raised to 4 as 5, 5 and 5. And see, this row can be divided by the number 5. So you will get 1, 1 and 1 here. So next row will be s raised to 4 is 1, 1 and 1. So you have constructed up to this level. So in the next level, when you are going to the next level s raised to 3, you can find that when you are taking the negative determinant, this will be cancelled out. So 1 into 1 minus 1 into 1 gives a 0 entry. So that you will put here, that is 0. And for the next entry, you can see you will take this column 1 and 1 and 1 and 1. So that also gives a 0 entry. So when you are taking the negative determinant and that will be divided by this entry, you can find that the entries in the rows s raised to 3 are 0 and 0. So that is the case for a all 0 row. So you should go through the steps, or you should go to the steps corresponding to the all 0 row in the Routh-Hurwitz criteria. There is a different procedure for solving such problems by using Routh-Hurwitz criteria. So once you met this all 0 row, you should find an auxiliary polynomial corresponding to this all 0 row. So that auxiliary polynomial is obtained from the entries of this nearest upper upper row. See, here is the entries are 1, 1 and 1, and by using these entries you can find an auxiliary polynomial corresponding to s raised to 3. So this auxiliary polynomial is the even powers of s. So here there are 3 entries, so you can write the even powers as starting from s raised to 4, that is s raised to 4 plus s square plus 1 equal to 0. That is the auxiliary polynomial. You can see here. So the auxiliary polynomial is s raised to 4 plus s square plus 1. You can see the coefficients are 1, 1 and 1. So keep in mind that when you are taking the auxiliary polynomial, you will take the even powers of s. So s raised to 4 comes first and then s raised to 2 comes. There is no term corresponding to s raised to 3. So you should remind that the auxiliary polynomial is written by taking the even powers of s. So this will be equal to s raised to 4 plus s square plus 1. So this is the auxiliary polynomial, and the steps to find the roots of this auxiliary polynomial is, first you should take the differentiation of this a with respect to s. So you will get dA by ds equal to 4s cube plus 2s. So that is the differentiation corresponding to this auxiliary polynomial, and its coefficients are 4 and 2. So you will replace the all 0 row by the coefficient of this one. So 4 and 2 are the coefficients, and you will replace the all 0 row by this 4 and 2. So you can write instead of s raised to 3, here s raised to 3 was s raised to 3 is 4 and 2 now. The previous case it was 0, 0. See, you can see here this is 0, 0 in the previous case. So you will replace this s raised to 3 by the coefficients of this term. The coefficients of this dA by ds is equal to 4 and 2. So instead of s raised to 3 you are writing 4 and 2. And here you can see that 4 and 2 can be divided by 2. So you will write s raised to 3 equal to 2 and 1. So you will create the root array by putting 2 and 1 instead of 0, 0. So you will get this like this, s raised to 3 is equal to 2, 1. And the rest of the root array will be keep the same. You will keep the rest of the root array as same as before, and you will replace this s raised to 3 0, 0 row by this s raised to 3 2, 1. So then you can proceed to find the root array by the same procedure. So next entry is s raised to 2. So you can write, you will get the entry of s raised to 2 by taking the determinant of this 1, 2, 1, 1. You should take the negative determinant and that will be divided by this 2. So you will get a value 0.5. So the steps are given here, that is 2 into 1 minus 1 into 1 divided by 2. Similarly, the second entry can be obtained by taking the determinant of 1, 2 and the next entry is 1, 0. So you will get this entry as 1. And you see, you can proceed in the manner, and finally you will get the s raised to 1s minus 3. So this is the steps to find the root array. That is the first step in doing the problem. So once you created the root array, you should mark the first column like this. You can go through the elements of first column. You can see that first element is positive, and here you can see that there is a negative element. So there is a change from here, all are positive, and there is a change from positive to negative. That means there is a sign change of 1. There is one sign change. So this sign change indicates that the system is unstable, or a negative entry in the first column of the root array indicates that the system is unstable. And here you can see that the number of sign changes is 1. Sign change means here sign change from positive to negative occur. That means there is a sign change of 1 occurs. That means this sign change indicates that one of the roots of this characteristic equation lies in the right half of the plane. See, this is an unstable system. In the case of unstable system, roots will be lying on the right half of the S-plane, and the number of roots that are lying on the right half of the S-plane is 1. So you can see that this is on examining the first column elements of the root array. It is found that there are two sign changes. See, hence the two roots are lying on the here. See, I made a mistake. See, sorry, there are two sign changes occurs here. See here, 0.5 to -3 and -3 to 1. I haven't noticed this one. So you can see that there is a 1 at the last one at the bottom side of this column. See, there is a sign change of two sign changes, that is 0.5 to -3 and -3 to 1. That means there are two sign changes, that is positive to negative and negative to positive. So two sign changes, that means two roots will lie on the right half of the S-plane. So that is written here, two sign changes, hence the two roots are lying on the right half of the S-plane, and so the system is unstable. So if there is the presence of negative sign in the first column indicates that the system is unstable, and the number of sign changes indicates the number of roots lying on the right half of the S-plane. So you find out that two roots are lying on the right half of the S-plane. So next you can find you can see that here there is a all zero row, and the presence of this all zero row indicates that some of the roots are lying on the imaginary axis, and you should find that roots. For finding that roots, you should take the auxiliary polynomial, that is auxiliary equation is s raised to 4 plus s square plus 1 equal to 0, and this is the auxiliary polynomial corresponding to all zero row. So the roots of this auxiliary polynomial will give the number of roots lying on the imaginary axis. So you should find the roots of this equation, and for getting the roots you are putting that s square is equal to x. So this equation become x square plus x plus 1 equal to 0, and you can find the solution by using the mathematical rule, that is minus b plus or minus root b square minus 4ac divided by 2a. So you will get the roots as x equal to this thing, but you know that s square equal to x, so you can find s will be equal to root of x. So when doing this procedure, you will get x as minus 1 by 2 plus or minus j into root 3 by 2, and s will be equal to plus or minus root x. So you will find again the square root of x terms. So you will get values plus or minus 0.5j plus j into 0.86 is one value, and other value is plus or minus 0.5 minus j 0.866 is other values. That means there are four roots corresponding to this auxiliary equation, and you can see that the two roots of the auxiliary polynomial are lying on the right half of the S-plane, and the remaining two roots are on the left half of the S-plane. You can see here plus 0.5 plus j 0.86 is right lying in the right half of the S-plane, and minus 0.5 plus j 0.866 lie on the left half of the S-plane. Similarly, here also one root is lying on the right half of the S-plane, and the other one is lying on the left half of the S-plane. And the right or left is determined by the positive and negative sign of the real part. That is, here minus 0.5 indicates that it will be on the left half. Here minus 0.5 will indicates that it will be on the left half, and plus 0.5 indicates that it will be on the right half of the S-plane. So there are two roots lying on the right half of the S-plane. So, and from the roots of the auxiliary polynomial, the right half of the S-plane, two roots are lying on the right half of the S-plane, and the remaining two roots are on the left half of the S-plane. And the two roots of the auxiliary equation are also the roots of the characteristic polynomial, and the two roots are lying on the right half of the S-plane are indicated by two sign changes in the first column of the root array, and the remaining five roots are lying on the left half of the S-plane. So now roots will be lying on the imaginary axis. See, here you got that two roots are lying on the right half of the S-plane, and two are lying on the left half of the S-plane. So for the instability case, roots will be lying on the right half of the S-plane. So two roots are lying on the right half of the S-plane, and here the equation has got 7 powers. That means 7 roots will be there. So apart from the two roots, 5 roots will be lying on the left half of the S-plane, and here from the roots you can see that no roots will be lying on the imaginary axis. See, so the system is unstable, and two roots are lying on the right half of the S-plane, and remaining 5 roots are lying on the left half of the S-plane, and no roots are lying on the imaginary axis. So that is the solution.